This is going to be an assignment for the majority of the semester, and I used to not introduce this until midterm. And what I've discovered is that there are a number of parts that you could be making to reinforce your skill set, make you faster and just a more confident draftsperson if you were able to work on this earlier. So I'm going over this now, and I'm going to open it up probably even before when the calendar says it's going to open, just so you have access. Now, this is from a magazine that is no longer in publication, and it focused on model steam engines in England, the UK anyway. The pictures are horrible. Don't worry about it. You don't need them. Here's the view that you need to put it together. I know because I have drawn every part of this and done this assembly multiple times. This is all you need. Are there some weird things about this? You betcha. And we're going to go over those now. First word of warning. All of these words in here are probably as important or even more important than the drawings. You need to read all of these words. There aren't that many of them. Another issue is that this was not drawn in any ANSI standard. This particular individual used fractions. We don't use fractions in manufacturing. We use decimal equivalents. Your role in this is in your drawing package, you will hold the decimal equivalent to whatever the fraction was that they called out. And you need to understand that. Will some of these be 9 decimal places? They sure will. But the person or engineer or whoever drew up this set and presented it called that out. So we're going to hold it. As stupid as some of them are, we're going to hold it. Just like real life. So we're going to go over each part individually, and this video is going to get rather long. I would pause right now. I would open up a Word document or a Notepad document or whatever you Mac people use to take notes, and type some stuff out. Totally valid is also a piece of paper with a pencil. That's fine. I'm just going to give you notes on almost every one of these parts on some of the vague areas that do exist. There is no real way for me to divide this up. I've tried drawing lines on this, and it just was a disaster. Everything is too close together. So you're going to have to pay close attention. We're going to go through this entire thing. Some of these things, the name of this part is brass. That's what we're going with. So we're going to start at the top. We're going to start with the base. There are only 2 views for the base. There's the top view and the front view. And let me zoom in a little bit. Pay very close attention to what is top and what is bottom. This particular part has holes, countersunk holes, coming through the bottom. These 2 outside holes here represent these 4, but they're looking through the side. And these 4 holes are represented in this view by these 2 stopped tap holes for a number 540. And again, I'm going to say this again, he's calling out fractions. You will never call out fractions unless you're building a house. That's the base. Let's come up here to the bearing. The bearing, 2 required. Going to throw a wrench in this. This says bushing optional. This bushing is not optional. This bushing is required. That bushing is bronze. So this is now a subassembly because these are 2 parts. These are now 2 unique parts. You have the bearing and you have the bushing and you have the subassembly of those 2 things put together. How deep are these holes drilled? I have no idea, but if I just look at it and eyeball it, I would say that they're about halfway through, right? These are stopped holes from the bottom to mount it. They look as though they're about halfway through. You are going to make that determination. That is going to be in your part, and you will carry that into your drawing package so that when someone looks at your drawing package, they will not have the same questions that you have. Your job is to answer every question. That's the bearing. The crank is steel, just like in Three Sisters. If I say aluminum, it's 6061T6. If I say steel, it's 1020. The bearing, couple of things. What is this radius right here? I have no idea. It's whatever that is. Put a fillet there and go, that looks about right. There is no rhyme or reason to it. The feature is there to lighten it. It's just to lighten it, that's it. Some people have asked me, is there a fillet here? Which is right here in this view. Is there a fillet here? I don't know. Could be if you wanted to. How wide is this from here to here? I don't know, but I will say that it appears as though the edges of this feature are in line with this boss. So I would say it's close to 3/8. So that's the crank. Shaft. This section view right here is just to make this part able to be drawn in a smaller space. Okay. This is not an actual feature of the part. It's just so that it'll fit on the page. There's nothing particularly complicated about this. It's just a cylinder with a turned smaller cylinder on the end. Ignore these callouts here. They are, the individual that drew this made up his own callouts. We'll discuss it later. For right now, they don't make any difference to you. Let's go over to the table, I think is what they call it. It's aluminum, so 6061 T6. Just like the base, pay attention to top and bottom because some holes are through holes, some holes are countersunk holes, and if you drill a countersunk hole from the wrong face, you have a problem. Not a whole lot of notes on this. The measurements are they're all there. There's no stopped holes. They're all through, but again, some of them are countersunk. Now, when you go into SolidWorks to drill a countersunk hole for a number 540, guess what you won't find? You won't find number 540 because a countersunk hole for a certain number of screw has no relationship to the number of threads. So you will find a countersunk hole for a number 5, but you won't find it call out for the number of threads per inch. Don't freak out. A number 5 countersunk hole is the same as a number 540 countersunk hole because there are no threads in this hole. This is a clearance hole with a countersunk for a number 5 screw, regardless of the threads per inch. Go over here to the arm. And this is a confusing mess here. Because this was a magazine article, they were limited to a certain number of pages. If you've ever written a magazine article, you would understand that you are paid by the page. So as the author of a magazine article, I would make my article as long as possible. So I would get paid more. The publisher, on the other hand, their job is to shrink your stuff to fit in the fewest pages possible. And that's why we have this mess for this arm. If you look, here is, we'll say that this is the front, bottom, left, and right side views. This right side view, totally cheating. This is also sort of a subassembly view. That's why it looks different. There are other parts involved in this. The only parts on this view that are actually this part is the end view here and here, right? Which is here and here and here, but you can't see the other one because of the view that it's in. This node is for the assembly. We're not going to worry about that for this. Column. There are 4 of them. You are required to use configurations on these. I'm going to say that again. You are required to use configurations on these. Make that note. You are not drawing 4 individual parts. You are drawing 1 individual part. You are making modifications to the hole type and hole location here. These 4 views here show the 4 different versions of this. They are aluminum. You can use the hex option if you want to. I find the hex option actually easier to draw on because there are surfaces to sketch on as opposed to the round ones I would have to create offset planes to sketch on. It's personal choice. I like hex personally, some people like round. Cylinder head. Ignore it for right now. It's too much. We'll have a whole lecture just on the cylinder head. Also, lagging tin plate, scratch it off. You're not making this lagging. This view here, where it says see text, actually see the text. This is not the part. This is the machining operation order to get the part made.